Hi, everybody. This is the last week of the theory and hands-on sections of the course. Your final will be coming up soon. So this week we're going to look at the final exam study guide. Sorry. That Scott Emmons put together for you guys. He's taken a look at the test. He's seen what's there, and he will be. I'll go over the study guide briefly. I'll also probably be discussing first the midterm exam again, and just basically giving you guys some updates on that. And then we'll take a quick look at client projects. David, are those up yet officially?
Mm-hmm.
All of them? Cool.
All of them are up.
So I'll go through that.
I'll be adding discussions right later today.
Okay, cool. We'll have some updates for that as well. And I'll, again, walk you guys through the process of setting those up for you. Oh, cool. So let's get started. So I'll first start with the midterm. We've updated all of the grades. So anybody who's taken the exam, take a look at the grades. There's one question I might be reviewing again on geographic. We might be updating one, giving half-point credit to some other people for one question, but it should affect maybe 10 people. But it's something that I'm going to discuss with Kadi, but I'll get into that later. Not right now. But I wanted to go over a few questions that I know we had some questions about. So I'll share my screen for a second, and I will give a short explanation of why I think there's been some confusion with some students. So let me share my screen for a second. Okay, cool. So a number of students have had some questions about question 7 that they received. In particular, this version of the question. We had some multiple version questions here. On temporal data. Is the time series of emails arriving in your inbox discrete or continuous? And a few students had asked me whether you could consider emails as continuous data, or if it was just simply discrete. And I think that there's some confusion, I think, that I can help explain. One way to think about emails are as they arrive distinctly in your inbox. So if you look at my inbox right now, and I can show you what that looks like. I think I can at least. I've gotten a lot of emails here, and if I were to look at just one of them, we're looking at the specific date. When we ask the question, we're asking, what's the specific date, the specific time that they have arrived at your inbox? We're asking for about one specific instance of data, and that's why we said it's a discrete answer. However, a few students have said that, well, what about the time, between when it is sent and when it arrives in your inbox? And that would be considered the latency period between the system transmission of one end, the sender, and when it's received by your email server on the other. And that, if we were to measure that, that would be a continuous data variable. That's not what the question is asking for. We might be updating the wording again next year to make this a little bit clearer, but it's a fairly, I hope that makes some clarifications there as well. And we also had some questions about burst analysis. And in particular, question 11, can burst analysis be used to identify common words such as stop words? And the answer is no. And it might seem counterintuitive because of what we've taught you to believe about burst analysis, and that it's capable of highlighting words, that are really significant within a series of text. The problem with that is that stop words are very common, and what burst analysis is actually looking at is the rate at which a word is being used in comparison to other words that are in the system, used in the algorithm. So a word that's used a lot, so if you were to say, if you had a common set of titles and they were all using the same language, eventually you might see a burst when a new concept is coming into the fore. But the second that it becomes very much, at a certain point, if it becomes into wide usage over time, then the bursting ends because it's occurring regularly within the data, and then it's no longer a burst. It's just a flat line within the algorithm. So in that case, stop words are really commonly used words, so they were going to appear everywhere, and they wouldn't be considered a burst. And another thing that would be also important to note here is that typically we're going to ask you to strip out those sorts of stop words because they're extraneous to the data. They don't carry any significant meaning. And while a burst might be able to find an inordinate amount of a certain stop word, it doesn't necessarily help with the end analysis. So that question should be no. Okay, I hope that answers those two questions. That sort of parallels with burst analysis are not sensitive to certain changes. So text format is sensitive to the format construction and the language that are used, but it's looking again for the rate at which a word is used rather than the frequency alone. Okay, and I think, yeah, and I'll go over one more thing, and let me just show you guys exactly a lot of the confusion that we had in the past was about some of the questions, and so these are some of the responses that we got to some of the questions that were given. In this case, this was one of the images that we were given, and this was for a word cloud. And in the end, we ended up accepting a number of answers, so chart, word cloud, tag, word cloud. There's a lot of variability in these answers, so that's one of the reasons why our system was initially only set up for a few common answers from the start, word tag cloud, and we didn't actually put word cloud for this answer because we had a very specific one that we thought people would answer. And going forward, we're going to be using these answers within the system to help make this a little bit better. But some things didn't count for full credit. So after coding by Kadi and myself, word weight normalization counted for some reason as half by Kadi. The word Wordle counted for 1 in this case, and alphabetized word cloud counted for half credit because it's really not about alphabetization. So in some cases, there's some variability that if you had some questions about why you only got half credit on some of these answers. Cool. So cool. So let me close this out. So let's look at the final exam. Let's talk about that. The final exam is going to open up on March, I believe, 3rd. Is that 3rd? Yeah. You'll have a week to take it. I can actually go show you guys how to get to it. Go to quizzes. You'll see that it will open up on March 3rd at 6 a.m. and it will be closed at March 9th. We've had some students complaining, or not complaining necessarily, but raise some concerns about the last midterm due date and openness. And that was open till the 19th on our part as an accident. But this mid-final will actually have just that week to take it. And we're pretty set on that. The exam is going to be 75 points. It's going to cover everything that's been covered within the last 7 weeks. We've opened up the midterm answers to the midterm exam so that you can review them and what's considered correct and incorrect. So you can go and review that and see, help review what you've missed and what you got correct. We also have this study guide, which is available at the link below the final exam. And it covers the major topics that are within the final for each chapter. And it will give you some definitions to know, be familiar with. And then really at the end, and this might be the hidden, actual lead here. One of the things about the exam that's unlike the final exam, the midterm exam, sorry, is that we were asking students to use Site2 to answer some of the questions and be able to perform some of the analysis and visualizations to get the answers that are requested by the exam. So throughout the last 7 weeks, you've been asked to do some hands-on activities such as burst analysis, geospatial analysis, co-occurrence networks, looking at trees, looking at topic visualizations. So I would go and review those workflows or those videos and be able to perform at least 1 or 2 of them, maybe 3 of them well enough that you could be able to answer a question. You'll be supplied with a data file and then asked to perform the sets of analysis on that data file. I believe it's NSF grants. So if you want to take a look at what those would look like beforehand, you can. That said, overall, I think it's the course. I believe when I've looked at the test, it's about half-half. So the first half of the course will be on about half of the exam, and the second half of the course will be on the other half. So about 35 points each, or 30 points each, not 35. Yeah. Cool. So. Sorry, was the question 6 answered? So question 6 answered. So, Suganya, I think, let me select that question. If I were to go back to the midterm quiz quickly. Question 6. Let's take a look at that for a second. I'm not sure, this might not be the exact question 6 that you got. Color value lightness. It's the wrong exam. Sorry, guys. Midterm exam. Let's go back to previewing this. Question 6, title. Ooh, okay. Title would be categorical data for this, so hopefully that answers your question. So hopefully that answers it. If you wanted to make some more clarifications, again, yeah, I would be happy to answer that if I can. Cool. So it was about choosing the type of graph and subset of questions. Okay, I can definitely go over that. Oh, here we go. Question 5, here we go. So let's go through this question, and I can give you some more hints or clarifications of what we're talking about here. So when you think of the data, given the data below, what is the best visual encoding for it? And if you think about it, what we have here is a city name, we have a longitude and latitude, the population, and then the cost of living. So if we think about city, if we think about this data, we know we have geolocation data, we have population, we have cost of living as a categorical variable, and then the city's name. If we think about what this data has in it, we already know that this should probably be a geo map of some sort, or, yeah, I would imagine. So if you were to take this data, and how would you I guess, visualize the best visual encodings for a geographical data set? So you might want to automatically go right to latitude and longitude, because we already know that those are position points. So that gives us a variety of things that we can do. So for a geo map, we generally want to label our points that we're doing. Because we're cities, these are going to be specific places rather than broader areas. And we could map onto the cities by boroughs, but that's not how the data is presented, or based on value areas like political boundaries. But those again aren't in the data. We just have city points. So that suggests that it's a proportional symbol map, and that's why we want to choose label here. So knowing that it's a proportional symbol map, think about how would you represent population and cost of living together. And population, I would use size, because if you think about population, it's a quantity that can have a range. It's a continuous variable. So the size can be proportional, linear, logarithmic, but that's really sort of the best way, I would say, to put it, size. Whereas cost of living, how would you use size to represent cost of living with a categorical variable? You would have either really small, a medium-sized circle, or a large circle based on just 3 sizes. And that might be useful for you, but it's less informative as far as how people normally think about cities in that data. So again, that's why we're choosing size here. And then color hue for cost of living, because color hue is very good at categorical data for choosing distinctions between high and low. And it's going to be a lot easier to read, at least as far perceptively, to choose color there. So I hope that okay, so let me go find that question, Suganya, and I'm going to go do the other version of this. So there are 2 versions of the question. So let's go to 6. Let me go to edit, and I'll show you guys the back side of this lovely grade. And let's go to question 6. So you're going to see this is the version that you guys, I just explained. This is the version that Suganya is editing. So in this question, you're presented with a description of the data rather than a data table. You have 10 university departments, and you are asked to create a visualization that correlates with gender imbalance and graduation rates. Then you want to know the departments with more women and men, and or equal parts that have the same graduation rates. Your client also wants the visualization to show the departments belonging to different colleges of liberal arts. So here are the data types that we would want to encode: the department name, the college, the percentage of men and women, and then the graduation rate. So we have 2 rate points as part of our data, and we also have the colleges and the department names. And what type of visualization really goes well with rates? This isn't, temporal data, because we don't really have the time periods, at least in this description of the data. It's not really it's not really topical. It's more of a statistical information. So in this case, the type of visualization that you want to be using is a scatter plot. You might think a line chart could be good, but again, that's more temporal data. A pie chart doesn't really show the dynamics that they're looking at, comparing 2 data points together. It's not a temporal bar graph, and it's definitely not geospatial. And while you might be able to do some sort of network encoding about if you had more information provided, scatter plot is really the answer that's best. And so once you have scatter plot, it actually becomes fairly easy. This becomes a position on the graph. Graduation rates become another position on the graph. College departments will become a label, and then the colleges themselves are going to be shapes, because you're going to have multiple departments for a college, and there's going to be it's going to be much, how do I put it? You'll have more shapes. If you were to try to put a shape for each college department, you'd have a very large amount of shapes, whereas you might only have a handful of colleges that are in a university. So shape would be better for colleges, and then labels for the departments that they're in. Cool. So I hope that answered your question. Cool. Let's go take a look at question 12. Let me go back. I'm going to go back to the old version of the questions that I was using before. So I have gone over question 12 already, but I'll give you a brief answer. Text construction, burst analysis is really measuring, at least in the way we've explained it, how text is used. So the language that you're using, the words that you the choice of words that you've got will definitely have an effect. How the text is constructed will depend. So if you're using titles versus an abstract, you have a very different set of text constructions. The title is much more condensed and to the point, whereas an abstract will have a lot more stop words and other use of other concepts and words that might be muddle an analysis or make finding bursts a little bit more difficult depending on how you set up your algorithm. And it's, again, it depends on the the format of the words as well. So I hope that helps answer question 12. Let's go to question 25. Okay, I'm not sure for these particular questions you definitely received a variety of answers. So depending on the visualization, you've been given the answers vary. So it would help to know which visualization you're asking about, Christian. Okay, and let me go to question 9 because this is a little bit easier to answer. Is stemming likely to lead to an increase or decrease in the giant component of a word? This is deceptive because stemming will make it more likely to add words to the network, but there's a counter. It's counterintuitive in the sense the reason that it's going to probably decrease the size of the giant component. How do you explain this to me? Basically, when you stem words, you're more likely to find commonalities within the words, but you're also reducing the links that are existing within the network because I should really feel like I should run an example. I might get back to you at the exact explanation as to why this is the answer. I'm not quite sure why we asked this question here. But I'll get back to you, Christian, about that one. And I'll post the response in the Hangout post. So I'm sorry I couldn't, at the top of my head, give you the response that's detailed enough and a good enough explanation for you. But I'll get back to that later. So, cool. So I'm going to stop talking about the midterm now. I've already talked about the final. So I'm going to go next to the client projects again. And I covered this a bit last week, but there's some news about these as well. So we've updated the client projects now to include everything. Question 25 is diagram. Okay, so Christian, going back to that one midterm question. So in the end, science map was the correct answer, but network was considered an accurate answer in the grade update. So where did I go? Let me open up the file. So, cool. So in this question, we ended up accepting network graph for half points. While this is a network visualization, for this particular question, we were asking about topical data. So as it was presented in that chapter, we were really looking for a science map because that's really what that's trying to encode, even though it takes on a network form. And network graph on its own doesn't necessarily explain specifically what it was. So everybody who answered network or network maps got some form of credit, just not full credit. So, cool. And I hope that answers your question. So let me go back to clients. So the client projects have been updated. Originally we had 10 listed, but we have added a number of things to these as well. Okay, why is this freezing on me now? So my computer's frozen, so I believe you can still hear me. I hope. So what's happening right now with the client projects are we've updated them. We have, I think how many, what are the totals now?
I want to say 19.
Okay. I think there are 19. I haven't done a hard count. Projects. They are all ranging in difficulty from fairly seemingly easy. There's some ones that are deceptive, and we had some questions in the forum that have asked me about those. Some that are much more difficult than others. So I could go over each of them individually, but it's better to maybe go read them, look at the data that they have available to them, watch some of the client interview videos that we've got set up. They gave some more specifications about what the project's entailing, what's going to be expected, how they'd like to interact with you, their sort of research goals and priorities as well. And you get to kind of see what they look like as well. Oh, why is this not working? My entire computer is locked up.
That's 19.
Okay, here we go. So as you can see, we have these different different guides. We've also added interviews, embedded them inside of the project descriptions with the different people. Some of these have been projects that have happened in the past, or at least so. Cool. Oh crap. Here we go. So take a look at these. One of your students actually has taken the time into the discussion forums and added some discussions that we're eventually going to pin after the final up to the top, so that you guys can, and I really suggest you go and look at these and ask questions. We are inviting the clients to come in to the course now, and hopefully they'll be able to come in and answer these questions themselves and provide some feedback as well. So we have all of these CPQ questions. Some of them have more questions than others. This is one on the age project. Some of them have responses. But what you'll see is that they range in a variety of ways on topics, from comic books, digital humanities. We have some information on Ebola and influenza from Thomson and Reuters, visualizing shopping behavior. This particular project is just for people that are in class at IU. So this is the project that only they'll be asked to join, because there's some confidentiality to the data that will be used. They have to sign, and they'll be working with one of the professors here in the university. But that's the only project that you won't be able to, as an IVMOOC student, to work on.
So I guess that means they'll actually have 18 for that.
Oh, yeah, 18. That's okay. So I would highly suggest starting to look at these, but don't worry about making your final decisions just yet. It's really a good idea to maybe go into the discussion threads and say, I'm really interested in this project. I want to work on this one. And once you guys have started getting a group of people together, Christian, can you send me the link to that discussion post in this question thread so that I can go right to it and take a look at it? Thanks. Once you get a client project, we are going to have you go to people. And once you're in people, you're going to see just a list of everybody, but we actually have these things called tab client projects. And once you're there, you will see we have about 20 projects set up. You can add a group yourself, but you can also go into here and you can edit its name, change its name to your group. And we're going to ask you to put your project name, the name that was given on the project, and then your group name after it. Basically, you flip it down, and in this case, Peter Samuel's already added one, but I can take on project 2, and I'll just type in my name, and I can drag my name over here, and then that person's now a member of your group. So if you know people that you want to add and you work with, just drag them over here, or they can do it themselves to join a group themselves. I can add, I'll add Kadi to my group too, just to show you what it looks like. Cool. And then to visit the homepage for your group, you click that toolbar, and then you go over here. And you have your client project page, and this is where we're going to ask you all to put your work. And not necessarily do all of your work here, but post your updates to your assignments. One of the things that we're going to ask you to do is build a page. So you're going to add a page here. You're going to give your title of your weekly client project assignments, and you're going to keep updating this page with your responses. So that way we can have a collective document that everybody can edit and see. And then we're going to share these documents with everybody else so people can look up the progress of other people that are working on different projects if they so desire. But you'll post your updates and your answers. Take this link right here, and when you submit the assignment, you'll use this link to submit your assignment, and you're going to submit an assignment for everybody in your group at the time. So I'll show you what that would look like. So if you were to go back to your home, you take your page link, you go to your assignments, and we'll have a whole new host of these client assignments here. So you would go into these particular assignments. This one hasn't been edited yet. You would submit your immediate proposal. Cool. You will submit that. You basically put your URL. You'll choose the group that you belong to, and then when you hit submit, all of your group will be able to have that notification across all of the people in your group, so that we can do simple grading that way. So there's less confusion about who's supposed to turn in assignments. One person can be the person that turns in the assignment for everybody. Cool. So let me go to the question that Christian was asking about. So let me select this now, Christian, and I'm going to go to that link. Theory video with whom terminology questions about figure. Okay. Why is the random network shown as a drawing with a normal distribution? Could it also be drawn as a uniform distribution? It's a good question. You theoretically could use a uniform distribution, but the random graph is defined within network theory has a normal distribution, but that they're randomly applied. And shouldn't the random graph also include the possibility of drawing from a uniform distribution? Any one node may be lined up with any other node up to a complete graph, where any other node is connected to every other node 100%. So that really wouldn't be a random graph then in that uniform distribution. But let me show you in situ sort of maybe what you're asking about. That's not good. So we can actually build some random graphs in situ. Cool. So if you're to open up Situ, you would see visualizations and modeling networks. Let's look at the random graph algorithm. Basically, it's a probabilistic, random graphs are probabilistic in their nature. So you're asking about what is the probability that one node will link to another. And it's based on a Gaussian distribution. You could have a Poisson distribution as well. And this is not necessarily where I'm the strongest, so I might have Kadi get back to you as well. But if we were to have 1,000 nodes and the probability of a linking, so what happens if we do one? Let's look at the network analysis. We have a density. Okay, it's going to take some time to go through this. While that's taking place, I'm going to also open guess. This might take some time, but I'll also look. Oh, here we go. So while you can build that random graph of a density of 1 where everything is connected to everything else, that quickly becomes, sort of less random and just a complete graph. So, the probability of the distribution then becomes, so let's just put this at a variety of things. Let's put 50% chance that you have a connection. And let's actually run an analysis here. Let me close that down. We're going to look at the degree distribution. Have to calculate no degree first. While it does that, this needs to be stopped. Cool. Now we can do degree distribution. This will take a while to calculate because there's 1,000 nodes. We're going to choose bins of 10. I don't have Java. Well, let's take a look again. Something else. This is an undirected graph. Why isn't this working? I have a suspicion. Okay. Well, I can't get this to work, but the degree distribution will shift as you change the probability parameters. I hope that answers your question. I'm not necessarily, sorry, I'm having some technical difficulties right now. It's not your fault at all. Guess is having some problems running the task. No, I don't. Don't try to fix it. There we go. Cool. So let me go back. Oh, okay. I guess I'll just put it this way, question. I'll get back to you about that. I have to do a little bit more reading on this topic to really give you an answer that's going to be meaningful at this point. It's been a while since I've looked at random graph information sources, and I'll post that back on in this particular question. And I'll maybe have Kadi come in and answer it. I think she'll have a better explanation than I would. So don't fret, you will get an answer to this question. It might just take us, I'll try to have something by tomorrow for you. Cool. Sorry I couldn't be more helpful right now, right off the bat. Cool. Yeah. I don't think there's any more questions that I could answer right now. So, like I said, I'll get back to you, Christian, with the response to this, and hopefully it will provide you some clarity, and me some as well. Cool. I will talk to you guys later. That's going to be the end of this particular hangout.